Hi everyone, it's Kim Lloyd again. We are going to get started with our presentation today. I want to thank everybody for taking the time out of your busy day to listen to us. We have and the title of the webinar is How High Performance Computing Help Companies Win SBIR and STTR Funding. We have a good panel of prestigious folks from around the state to help us discuss this topic. We have a list of speakers here, and we are recording this webinar, so you'll be able to get a copy of it and check out the speakers that are here today. What I'm going to do now is go ahead and introduce Jack McGowan, who is with Insight Consulting, and he's going to give us an introduction as to he's going to give us an introduction to SBIR. Take it away, Jack.
Good morning, everyone, and welcome. Kim, if you could move to the next slide, please. And the one after that. Great. Just a very brief overview of SBIR, STTR. Hopefully most of you have heard of the program, but it's a federal program that funds keywords, innovative R&D, and strong commercialization potential. 11 federal agencies participate in the SBIR, which is Small Business Innovation Research Program, and 5 of those agencies also participate in what's STTR, which is Small Business Technology Transfer, and I'll talk about the difference of that in just a moment. It's a 3-phase program. Phase 1 is really an initial demonstration of technical feasibility or prototype. Each of the 11 agencies have their own solicitations, and they all have different nuances, different amounts, different due dates, but typically phase 1 is somewhere in about $150,000 for 6 months, sometimes a 9-month work plan, but that amount can vary by agency. It can be higher or lower. The next step, phase 2, is really the bulk of your R&D effort. That's when you'll be doing the full research and development, and that's what you're targeting for, where phase 1 is sort of a test where the government hopefully will, you'll be able to demonstrate good initial results and then apply for phase 2. Phase 2 is the bulk of your work. Typically $1 million. Again, it does vary by solicitation and by agency, and typically about a 2-year work plan, with the objective being, at the end of phase 2, you've pretty much got a product that's ready for commercialization, which is phase 3 in SBIR parlance, the commercialization phase where you as a business are out commercializing. There is no SBIR money, so you don't apply for a phase 3 to do that, but that's certainly the expectation. A couple quick notes. The applicant for an SBIR must be a U.S.-based for-profit small business. That means less than 500 employees, so most companies will qualify for that. And one thing that's important to note is that there's real money here. New York State companies have received 238 awards for almost $100 million in 2014, which was the last year of full results have been reported. Next slide, please. So one of the keys is, how can you collaborate as a for-profit small business with not-for-profit research institutions such as the HPC, which we'll be hearing some good examples today. So in the SBIR, the applicant is the for-profit small business. One of the important distinctions is that someone must be designated as a principal investigator, who is the person who is in charge. They don't necessarily do all the work, but they oversee and have the primary responsibility for overseeing the work that's been funded through the grant or the contract. And that person must primarily be employed by that small business, which does preclude full-time employment elsewhere. So that's an important point to be aware of. And in an SBIR, that for-profit small business may subcontract up to 1/3 to outside entities. So it could be a not-for-profit research institution like a university or one of the HPC centers, or it could be another business. STTR, the nuanced difference there is that it's a joint submission by that for-profit small business, which is the lead, but it is in collaboration with a nonprofit research institution such as the APCs. One of the benefits of STTR is that the principal investigator may be employed by that research institution. So if that person is really the best fit, STTR is an advantage. And also the other advantage is that in an STTR, although the small business must do at least 40% of the work, the institution can do a larger percentage than a third. So if the expertise and the resources lie significantly at the institution like the HPC, STTR could be a better fit.
Thanks, Jack. I should have mentioned earlier that at the very end of this presentation, we will be leaving about 10 minutes for questions, so you'll be able to, and feel free as speakers are speaking to type in your questions, and I will pick some at the very end of the webinar to address to the presenters. Next, we're going to have Mark Shepard from RPI talk to us a little bit on high-performance computing.
Yes, good morning. So introducing high-performance computing, the first definition given on this slide is one used by the HPC community. I'm not even going to read that one. I'm going to focus on a definition I tend to use in interacting with industry, and that is the fact that HPC allows the application of computing to perform simulations that will increase your understanding of the behaviors that are relevant to your product development activities, to provide quantification of uncertainties related to various product parameters, to support cost-effective development of new products, and to be able to optimize product designs in to meet specific customer requirements. And we've been involved with activities, if you will, that address each of those quite specifically. Next slide, please. Okay, this slide says a little bit more about what HPC is and the fact that it's often equated with parallel processing. Just 2 points I want to make on this aspect of it, and that is that typically as you start using computing in a more heavier basis in the product design and development, you will find that the level of calculations you need will push you to parallel computing. The other aspect is as we proceed forward and you're using large-scale computing, what I referred to as supercomputers are actually very cost-effective, primarily from their use of energy. They use much less energy per calculation, if you will, than other machines. This tends to introduce some roadblocks for small business in the application of high-performance computing, because you need access to the software that can do the jobs you need. You need access to the hardware and dealing with the difficulties of using it. And often when we're working with businesses, both small and large, it's also access to the technical expertise required to really develop the HPC simulation workflows you need to be productive on it. And that is where the High Performance Computing Consortium, HPCNY, can come to bear for particularly New York State companies, although they could be broader than that, but certainly the money supported by New York State is for New York State companies. We will work with you on overcoming these roadblocks. Next slide, please. So the mission of the HPCNY is to bring together a collective expertise and resources of New York State's top universities, advanced computing centers, and economic growth centers to really help companies use high-performance computing to meet their business needs. What is it we actually provide? We actually can provide the high-performance computing resources themselves, the computer hardware that you can be able to run these large calculations on. Because they're not trivial to use, we also provide direct support on how to use these high-performance systems related to the simulation software. In addition, we provide technical expertise in the development of the simulation workflows that are relevant to you. and can work with you on developing the funding. Several of us are faculty members, if you will, and part of our job is writing proposals, so we're pretty good at that, hopefully, otherwise we don't get tenure. So we can help work on that. Also be involved with developing multi-way partnerships, and we often know many of these agencies fairly well that are giving out SBIRs and STTR'S. Next slide, please. This slide summarizes the membership of the HPC Consortium. I'm not going to run down that list other than indicate 3 of the consortium members are actually going to follow giving presentations of examples of how HPCNY has been working with companies, in particular emphasizing our interactions with small businesses. Now, I do want to acknowledge the fact that we are directly supported by New York State specifically to work with New York State companies, but we also have other related federal research grants that are supporting much of our R&D efforts on developing technologies we use for this, and we do have companies directly supporting us on specific activities past, above and beyond, if you will, what we do at HPCNY. Last slide, please. Okay, so this slide just indicates that we are attuned to working with small businesses. As you're going to see from the examples, we have worked very successfully with a number of small businesses on developing SBIRs and have taken specific advantage of the New York State funding to do the work on the development of preliminary capabilities that need to demonstrate the ability to win an SBIR, as well as helping to write SBIR proposals. And I believe I'll end my comments at this point to leave time for the other presenters to actually show you the examples, which will be much more enlightening.
Thank you, Mark. Appreciate it. Next, I'm going to introduce some folks from Sentient Science, introduced to us through their work with Sean and their crew there at University of Buffalo, Dr. Eva Wu and Jennifer Haggerty. Jennifer, take it away.
Hi, thanks, Kim. Hi, everybody. So this first slide just shows some of the government agencies that our company has worked with. Our company started by developing and validating their technology through government funding. So the SBIR and STTR programs were very important to the growth of our company. And we started with a win from DARPA in 2001. And so we've worked with National Science Foundation, NASA, Air Force, Army, and various other government agencies, and continue to work with them to develop new features and parts of our technology. And it's been a great way that we've been able to take our ideas and bring them to market. So our company, really the technology that we've built is a computational tool. We have a software as a service model, so we are very much software driven. So HPC resources are key to us getting our job done and making our customers happy. So we are really a team of engineers creating material models from the microstructure up, and using the computers to simulate how the materials interact and perform at a component level like a gear or bearing. And we use the computing power to predict how long these components will last, when they might fail, when rolled up to a system level application like a gearbox or drivetrain. And our first commercial market was in wind. So we have this plethora of tools, and given that we have high fidelity models that we're creating, it's contingent on having access to these powerful resources. So in trying to build up and scale our technology, we needed a partner. And so we found a partnership very much through the consortium that Mark Shepard mentioned, and we were funded on a Department of Energy SBIR for taking our computational models and addressing some of the typical issues businesses have in terms of scaling our computations, improving speed and accuracy, and properly utilizing the HPC resources. The University at Buffalo Center for Computational Research has been phenomenal in working with us to help write our proposals, identify funding sources, and so for this example project funded the DOE project. This one is focused on taking our complex models and creating simpler models called surrogate models that can do computations faster, all built on our core physics-based technology. And so we've been already able to see some of the benefits in terms of speed ups in our computations, being able to predict the performance of our assets for our customers with a high level of accuracy, and we continue to work with the University of Buffalo on optimizing our usage of the resources, and it's just been a phenomenal relationship. And with that, I can pass it to Dr. Eva Wu. She is the principal investigator on this example project, to give you a little bit more about that.
Thank you, Jennifer. Hi, everybody. This is Eva. I'm going to give you a general description of this HPC-enabled meta-model system. So from the top, we have our sentient physics-based model, and we use HPC resource from UB to run hundreds and thousands simulations and create a database. Using that database, we can create a meta-model which represents the input and output of the original physics-based model. But this meta-model runs much faster than the original model. So we also create a web-based user interface. User can use the meta-model to do fast screening, real-time tests, and they also can have access to the physics-based model and HPC resource to do the high fidelity, high accuracy test. So this is a system. Next, I'll show you two examples using this system. So the first example is based on sentient DigitalClone component software. We use 4 input parameter and 1 response parameter from the physics-based model, and then we're using design of experiment to properly sample the design space and create the meta-model. The response surface of the meta-model is shown on the upper right. We projected it into a 2-dimension, actually it's a 4-dimension design space. And using this meta-model, we can do interpolation prediction. And this is how the HPC-enabled meta-model makes the simulation run faster. In the next place, this is another case. This is a groundwater model. Actually, it's from Sean from UBCCR. So his model, there are 5 input parameter and 1 response. And we use the same technique using the same system, create a response surface. And for this case study, we use this meta model for optimization. We can see that the input parameter have a large range. And using the optimization based on the meta model, we can quickly find the optimized design in this 5-dimension design space. So next, please. So that are our accomplishment during the SBIR Phase 1 project. And for the long-term goal, for the goal at the end of the Phase 2, we are trying to create a web-based computational living tool to allow our customers, most of them are in wind energy, and they can access our software, access HPC, and design their own component on the website. And then either they can run the rapid metamodel-based test, or they can use in HPC to run the high-accuracy physics-based test. So this is our vision of the final product, and we are working towards it. So thank you.
Thank you, Eva. Thank you, Jennifer. Okay, next I'm going to hand it off to Cameron Smith, who's a computational scientist with RPI. And he's going to go through some activities that they have done.
Okay, thank you, Kim. So the RPI group is focused on putting together HPC simulation workflows using a combination of academic, open source, and proprietary HPC components to address design and engineering questions that our industrial partners have. One of the main focuses of these workflows is to be able to scale them from the workstation level all the way up to the clusters to the world's largest supercomputer systems, such as the ones at the national labs, which we do have access to. In particular, these workflows that are developed are part of our SBIR and STTR proposals that we write, get funded, and execute with these companies. Next slide, please. So SCOREC has been taking advantage of many years of proposal writing skills, both within the SBIR, STTR program and elsewhere, nationally at the Office of Science and so on, to gain more SBIRs and STTRs with different companies. To date, we've worked with 4 different companies as the lead on SBIRs and STTRs. Those projects have involved 8 different RPI faculty as PIs and co-PIs, and is built on their research expertise in fields such as parallel unstructured mesh methods, computational fluid dynamics and solid mechanics, microstructural modeling, multi-scale methods, MD to finite element continuum, and some including finite temperature aspects, fluid structure interactions, optimization and control, and more recently, uncertainty quantification. One example of a interaction with a company, but that lies outside the SBIR, STTR program, is this twin screw extruder viscous flow problem with Corning that Professor Onkar Sahni worked on through a research collaboration with them. So here we had challenges of meshing this domain with small gaps and large feature scales, and properly modeling the flow physics involved. So this is our first example of an SBIR. Go back one, please. Kim, can you go back to the Pliant slide 2 back?
Sorry, I didn't click it. It was an accident.
No problem. No problem. So this is an interaction with Pliant Energy Systems. They're a small startup in Brooklyn, New York. They're developing complex energy extraction devices. The images on the right are portraying this piezoelectric ribbon that's submerged in a channel of fluid. As the ribbon is displaced by the fluid flow, electricity is generated, and they get their product. The key development here has been on both validating the model for fluid structure interactions as this device moves within the fluid and subsequently affects the fluid flow, and reducing the cost of modeling these interactions. The result has been a reduced model that the engineers can use to test new device configurations very quickly without having to modify or reconfigure their existing physical prototype devices. And through our simulation work with Pliant, they've won SBIRs and have subsequently funded our research with them. Next slide, please. The next interaction is with a Albany-based ceramics manufacturer, Blasch Precision Ceramics. who is looking to define multi-physics simulation capabilities that can support custom customer-specific designs of their vector wall high-temperature baffle wall, which is what you see in the top right. This is inside of a large exhaust stack, where these sculpted sections are controlling the flow circulation, as you see in the bottom right, of the gases as they flow through the stack, and subsequently increase the efficiency of the chemical reactions happening within, and can reduce the outgoing pollutants. So Dr. Max Bloomfield has worked with the Blasch engineers to develop a analysis workflow that can be executed on a desktop, and subsequently the sales engineers have been able to use this tool to analyze custom configurations for customers, and in the last year have noticed or have gained an increase in their sales of this product because of that capability. It's worth noting that this interaction is a sort of three-way partnership with the RPI Future Energy Systems CAT, HPCNY at RPI and Blasch, and is supported by the New York State Pollution Prevention Institute as well. The next example is with Simmetrix. They're a Clifton Park software house that is specializing in HPC component software to support the kind of workflows that I've been highlighting so far. One of their key strengths is in mesh generation, mesh adaptation, and handling complex geometric domains. And the figures in the top right, and clockwise from upper left, is a fission reactor where you have complex fluid structure interactions that have to be modeled, the full automotive underhood analysis, mesh and capability, a evolving material microstructure analysis, and lastly the curved elements through the thickness of a linear accelerator model. So with Simmetrix, we're advancing the capabilities of these meshing and geometric capabilities out to the largest parallel systems available. And as a result of the sophistication and capabilities of these tools, we're engaged with additional projects with IBM, Boeing, and other industry leaders in simulation, as well as have DOE collaborations. And in addition, there's 4 ongoing SCOREC subcontracted SBIR STTR'S with them. So to wrap up, we have 2 ongoing phase 2 SBIRs and STTR'S with DOE and DOD. And next slide, please. And 3 phase 1 DOE and DOD SBIRs and STTR'S. It's worth noting that on some of these calls, we work closely with the program manager to understand what the call language is, and give feedback on that, and likewise work very closely with companies in responding to these calls. So thank you.
Thank you, Cameron. Next, we have Dr. Jason Trelowitz and Dr. Soterios Mamalis, and they're going to share some case studies from Stony Brook University.
Thank you, Kim, for that introduction. So here at Stony Brook, we put together a model for the High Performance Computing Consortium out of our Institute for Advanced Computational Science, where we pulled together a rather large team of faculty and staff here at the university with expertise in computational science, engineering, programming, large-scale data and data analytics, as well as visualization for various simulation packages. So we currently have faculty that span our College of Engineering, from departments such as mechanical engineering, chemical engineering, material science, computational chemists from the College of Arts and Sciences, as well as a number of faculty members from our Applied Mathematics and Statistics department. And looking at the cross-section of individuals working on the projects, we really span the full range of available modeling to work with companies. So everything from atomistics and molecular scale modeling to computational fluid dynamics and other continuum level approaches, as well as software design and engineering. Next slide, please, Kim. So we have, over the past year and a half, developed a portfolio of companies that we are working with, and it's typically done through one of the faculty members leading the project, and we regularly get together to discuss updates, to collaborate amongst the group. And here's just a list of some of the companies that we're working with. The first two, Thermolift and Innoveering, are both smaller startup companies. Well, Thermolift is, Innoveering's a little bit larger now, but really focused on engineering solutions. And both of these projects are really falling under continuum level type modeling, computational fluid dynamics, as well as finite elements. We had a recent project now expanding to more of the art side with Pigtronics and a faculty member in Applied Mathematics and Statistics, as well as the music department, looking at developing models for new digital audio capabilities. Then we have a handful of products, I guess 3 projects that are focusing on molecular modeling. One with EOS Energy Systems, looking at modeling hybrid batteries. One that actually recently completed, and they were successful in getting a Phase 2 SBIR award with Sulfcrete, where we were doing molecular dynamics simulations for sulfur crystallization. And another one looking at new materials for fusion reactors. And then a final project right now where we are developing new types of source-to-source translator technologies for use with the R language. So what I'll do is I'm going to pass it over to my colleague, Dr. Morales, to discuss his project with Innoveering, both what some of the technical focus has been, how the high-performance computing consortium has contributed to advances on the technical end, and some of their real success stories on acquiring federal funds. These are actually going to be focused on other sources, not necessarily SBIR, STTR, but Innoveering does have a number of SBIR, STTR projects that uses other type of high-performance computing resources.
Thank you, Jason. Hi, everyone. In the following 3 slides, I would like to discuss about the project that we have with Innoveering LLC, which is a local company over here at Long Island. And they have a technology that they call fuel reforming, which is used to basically to restructure some of the liquid fuels that are used in heavy-duty engines. And the restructured fuel can be used to improve the thermal efficiency and reduce the emissions formation for heavy-duty diesel engines used primarily by stationary power generation. So the project is focused on utilizing high-performance computing and computational fluid dynamics to simulate the combustion process in the cylinder. And what you can see here on the right are a couple of pictures that show the model formulation up top. This is basically an engine cylinder and the intake and exhaust ports that are modeled in CFD. And then the bottom picture shows a visualization of path lines during the intake stroke of the engine itself. The model is physics-based, so it includes a lot of detail regarding fluid mechanics, combustion chemistry, moving boundaries, variable volume. So it's a very robust model. And this slide shows an example of results that can be obtained by running these kind of simulations. At the top right, we can see the evolution of the CO2 mass fraction during the combustion process, which is basically a tracker for the flame as the flame propagates. This specific case is on natural gas combustion. So we started from natural gas and we will move on to diesel combustion later on to prove that this technology is effective in multiple applications. And the bottom plots show, on the left show cylinder temperature, and the right show NOx concentration. NOx chemistry is highly dependent on cylinder temperature, so by running our simulations to calculate accurate values of the temperature of the cylinder, we can predict the NOx emissions in the exhaust. If you go to the next slide, you will see that this kind of collaboration with Innoveering spurred additional work, and we were able to secure some federal funding. This specific one is not SBIR, but is general funding that came from DOE ERE and also from ARPA-E. Both of these concepts, both of these projects involve heavy use of computational dynamics, high performance computing, and also the second one, the DOE ERE program, was also one collaboration with Innoveering, who have a sub-award of $190,000, which is a little larger than a phase 1 SBIR. This project is 3 years in duration, and this was our first attempt actually to write a proposal with Innoveering. Was successful, and we look forward to completing this project and following up with additional proposals in the future.
Thank you guys so much. I appreciate it. Next up, we have Marcy Sonneborn. She is with Center CNY TDO, and she's a specialist and part of the Manufacturing Extension Partnership Program. And she's going to talk about MEP and collaboration with the HPCNY network.
Thank you, Kim. The NIST the Central Department of Commerce, National Institute of Standards and Technology Manufacturing Extension Partnership Program is funded throughout the entire country, and in New York State we have 10 centers and these centers are based at the Regional Technology Development Centers. These centers provide assistance to manufacturers, technology companies, and the types of services include training, technical support, and they can be direct or through regional universities and organizations, including Empire State Development funded Centers for Advanced Technology, and there are 15 of them within New York State. Some of the programs, Growth and Innovation, includes SBIR at a couple of the centers in Buffalo and in Central New York. Team development through university and industry, maybe putting together connections and personnel in regional companies. It may include corporate partnerships, access to intellectual property sources, and also access to business development sources, which may include legal, accounting, commercialization assistance, and planning. For technology acceleration, as I mentioned before, the 15 Centers for Advanced Technology, but connections may also include design engineering, prototyping, and manufacturing support from other locations. Lean and continuous improvements are for companies that are setting up or expanding their manufacturing or business capabilities. Export services include commercialization into global markets, also getting access to trade missions and other export services, including individuals that have expertise in these areas, including trade specialists. Supply chain is when working on commercialization planning, how to connect upstream and downstream to other types of more commercial type funding. Technology, since technology changes over time, also access to new technology, and in many cases being able to go in and assist with how does one make connections to new technology that is starting to be developed or emerging. And then it may also include personnel training in the sustainability category. Workforce may be hiring trained individuals that potentially are new to the area or coming out of PhD or other academic programs, but also connecting with New York State resources such as the Workforce Development Institute in order to get training programs funded that are obtained from the regional technology development centers. Next. So the NYS MEP centers and high performance computing centers work together to connect technical resources across New York State. Local MEPs are aware of the capabilities of manufacturers in their region, can make connections there, and then on the high performance computing side, supporting small businesses need to connect to digital business environment, especially as we're starting to talk about the Internet of Things and networks and supply chains. Next.
Okay.
Tim, back to you.
Thank you so much, Marcy. I appreciate it. The presentation that you saw today, we're going to open up for questions in a couple of minutes. Please feel free to start typing in your questions into your question window. There should be an ability to raise your hand in your GoToWebinar control panel. So feel free to start directing questions there so I can share that with the panel. In the meantime, I just wanted to let you know that FuseHub is here. You've heard from a lot of different people today. You may not even understand how to get started with SBIR, STTR, or even how to apply high-performance computing. So go ahead and contact me or contact FuseHub. We're part of the MEP system, and also our funder also supports the HPCNY system. So go ahead and get started with us if you have further questions, and we'll make sure that we route you to the correct resource. So I am going to go ahead and address a question here. This webinar is recorded, so I will be, as part of the following up with everybody onto the webinar link. So that is going to happen. One of the questions, and I'm going to unmute everybody here while we're talking. One of the questions that I think that everybody might have is that around how do I know, based on this webinar, how do I know how to apply high performance computing to my particular manufacturing business? How do I know what to use from high performance computing? Is there help available to understand that? Does somebody want to take that question?
This is Mark Shepard. I can take a very quick first cut at that. In many of the cases, that's not really known. That's part of the process, is having discussions with the companies who believe there may be a possibility to, and see if we can identify that possibility and then make a match with the appropriate expertise to help develop that, to determine how HPC could be applied, and if that really makes sense, to then start moving forward to putting the capabilities in place with that company, directly meeting their needs.
Great. Anybody else want to respond to that?
This is Jennifer from Sentient. I would just add that that's really exactly how we went about it. We had computational experts developing the code and our algorithms that we wanted to run on HPC resources, but we just began the conversation with the consortium members, and it was very much a two-way street, and we identified those funding sources to help answer some of the questions particular to our technology.
Great, thank you. Another question here, how much does it cost to help prepare for an SBIR Phase 1 application? What's the range of costs that we can expect? Can anyone answer that?
This is Marcy. It depends on what you're going to do to prepare. If you have internal personnel, it's going to be your allocation of the personnel time. if you're going to be hiring an external consultant to write the proposal, that is a sort of a mixed bag in terms of capabilities. What do they require to write your proposal? In some cases, they take equity in the project. SBIR cannot fund that directly. So it really depends. Generally, I once knew a company that said that they could put a proposal together in about 2 or 3 hours, but that's because they had everything within their computer system and they put everything onto their network. But for the most part, it takes at least 2 hours or 2 weeks of someone working full-time to get all of the pieces in place. You need the technical aspects, but you also need to have all of the registrations in place many, many weeks before, probably 6 to 8 weeks before that. You should be registering to be a federal contractor, then to be registered as a small business concern, and depending on the agency, there are up to 5 different registrations that you have to have. And so it depends on what you're including in your question and how well your team works together and what are the capabilities that you have. And have you ever submitted a proposal before, even if not to the government, but for proposals for industrial contracts? So a lot of that depends on where you're starting, where you're going, and what is the depth of assistance that you require.
This is Jack McGowan. The point to be aware of, though, is that the assistance that is provided through the New York MEP, and we won't be writing your proposal for you, but working with you through the process. That is a free service, so there's no direct cost to you for our assistance.
This is Jason Frolowitz. I would also double the 2-week time period if you want to reach out and engage the program managers for specific topics, which I highly recommend doing. So if you wanted to, if this is something you're doing initially, I would give yourself a good month before the due date to be dedicating a person's time to preparing the SBIR application.
This is Mark Shepard. I'll just comment on our specific experience as much as anything else, in that we've been involved with, as Cameron indicated, a number of SBIRs and STTR'S, and if you will, our involvement usually involves developing a subcontract, and sort of part of the upfront price for us being involved with that and being included for a subcontract is that on most of these, frankly, we end up writing almost the entire technical section, and the company will write the commercialization plans and the integration aspects, and have to go through the submission process. And of course, with the technical part, we're iterating with them, but very often we'll take the lead. We'll take a big part of the lead on helping define the technical aspect of the proposal based on what their skills and what they're addressing, and put a lot of that together. And that's something that, and that's one of the advantages of having HPCNY. We can get an initial start on some of those things to see if it makes sense.
Great. We have time for one last question, which is, so somebody said that they've been unsuccessful in going after SBIR, STTR funding on their own in the past. Would partnering with the MEP and HPCNY help allow them to maybe potentially rework that and go back out to try again?
This is Marcy. It depends on what was in the feedback from your agency and why did you not get the proposal. So that's something that you need to make sure that you have a clear understanding about that, and if you were able to get have a conversation with the agency and to talk about that further, that may be beneficial. There are lots of reasons why an agency may not, or a company may not get funded. It may have to do with your technology, and maybe something has already been funded in the past in that area, or it could have to do with your team, may have to do with any collaborations that the federal agency has had in the past, and therefore someone was much more familiar than you are. or it could have to do with a number of other reasons. Maybe your proposal wasn't written very well, and in some cases, it has to be very clear with white space in it so that a reviewer can quickly identify what are the important points, how are you different from everyone else who's out there, and what is your contribution. Or it may have to do with, sort of what you're going to be doing in a commercial market, and maybe that doesn't fit. But usually it's all of the other things before that. Jack, anything to add on that one?
No, I think you summarized it well. I mean, I think really need to find out why didn't it get approved, and then work from there, because there are a lot of different elements that go into the evaluation.
Great. Okay.
I would say from
go ahead.
Kim, maybe just to add from the HPC side, if there's a particular aspect that is difficult to ascertain through experiments, there are a number of different types of modeling that could be brought to the table to help strengthen the contract. And the additional benefit is many of us on the High Performance Computing Consortium have prior experience either working in industry, writing many SBIR proposals, and as Mark alluded to earlier, his team does that regularly as well, and we do that at Stony Brook. So it could be both the technical benefit as well as helping through the proposal process as part of the collaboration.
Great. Thank you, Jason.
This is Mark again to comment on that. I mean, for example, with Pliant, when Pliant was talking with the potential sponsors of their SBIR projects, they were specifically pointed to that they, it would very much strengthen their proposal to have some computational modeling of their systems, and that's one of the reasons that they engaged us. The other quick comment I would make is that, and again, it's somewhat local, but our success rate is well over 50% on these proposals. We've got it down pretty well as to how to structure them, although that doesn't mean it's not. It's really fast. I mean, the technical part of these does take a lot of time to do all the background work to iterate on what's the right things and then to get the right technical backup into that in terms of references and making sure one's current with what's out there.
Great. Well, thank you so much. I appreciate everybody's time today. I will be sending out a link to the recording within the next 48 hours. Thanks again for everybody's participation. Feel free to reach out to me and to FuseHub with any questions to connect you to the correct resources. Thanks again. Bye-bye.